Hello everyone, welcome to Numeriq Learning. So today is day 16 of daily practice series wherein you will be taking your notebooks and doing problems with me. You will pause the video. So every day we will be spending around 20 minutes approximately, Monday to Friday or even Saturday, and we will be doing problems. And if you have any doubts, you will definitely, without a second thought, you will post it in the comments and I'll reply to them. Okay, so today we have got some three problems from the chapter Polynomials. Let's get started. The question is, if alpha and beta are the zeros of the quadratic polynomial, f of x is equal to ax square plus bx plus c. So what you are given is a standard quadratic polynomial. You have to evaluate two questions under it. You have to find the values of 1 by a alpha plus b plus 1 by a beta plus b, and the second one also, which is in terms of alpha, beta, a and b. Let's get started with the first one. Okay, so the very first question, let us assume that let alpha and beta are the zeros of the polynomial f of x equal to the standard quadratic polynomial ax square plus bx plus c. Okay, so the minute you have your quadratic polynomial, get the sum of the zeros alpha plus beta equal to minus b by a, absolutely no change in it, and alpha beta product of the zeros is equal to c by a. Okay, now what you are asked is write the question as it is. 1 divided by a alpha plus b. I'm just writing the given question. This is the first question and then we will solve the second one. Okay, so using this quadratic polynomial, first of all we have found the sum of the zeros and then the product of the zeros, and now we are evaluating or simplifying this. So 1 by a alpha plus b plus 1 whole divided by a beta plus b is the question. The very first thing is take the LCM. The LCM will be the product of the two terms, that is a alpha plus b multiplied by a beta plus b. In the numerator, how will you write the LCM? So this term a alpha plus b multiplied by what will give you this entire product. So you have a beta plus b. This you have to multiply it with the numerator 1. So what will be the first term? It will be a beta plus b. Okay, and then the plus in between, and again a beta plus b is already there, so you have got a alpha plus b multiplied by 1. Okay, so you have a alpha plus b. Now let's combine. You can see you can take a common out from the first and the third term. Okay, so in the next step we will take a common out. You have alpha plus beta plus, what is b plus b? It is 2b. Okay, so plus 2b whole divided by, multiply each term. So a alpha into a beta. What is a alpha into a beta? It is, let me write it and then I will expand it. Okay, a alpha into a beta plus a alpha into b, right? The first term with the first two terms, a alpha into b, and then plus b into a beta plus b into b, which is b square. Okay, so this is what you have multiplied your denominator term. So the numerator term remains as it is, a multiplied by alpha plus beta, because we know the sum of the zeros, plus 2b whole divided by, now let me multiply. So this will be a square alpha beta plus ab alpha plus ab beta plus b square, right? Now again, I am not going to change the numerator, a multiplied by alpha plus beta plus 2b. In the denominator, the first term will be a square alpha beta. Again, I am not going to change it. In the second and the third term, I can take ab common out. So what you will be left with is alpha plus beta in the bracket. So ab common, you will have alpha plus beta plus b square. Now let us substitute. What is the sum of the zeros? Minus b by a, product is c by a. right? So instead of alpha plus beta, I'm going to substitute minus b by a. Instead of alpha beta, I'm going to write c by a. Let's do that. So here a multiplied by alpha plus beta minus b by a plus 2b whole divided by a square multiplied by c by a plus ab multiplied by minus b by a plus b square. So a gets cancelled in the numerator. Again, the denominator a square and a here also. Whatever gets cancelled, you can do that. And what is left in the numerator is minus b plus 2b whole divided by, in the denominator you will have the first term is ac minus b square plus b square. This is what remains. Minus b square plus b square gets cancelled. What is 2b minus b? It is just b. B divided by, in the denominator you have AC. So this is your final answer. So in order to get, each step has to be correct. Only then you will be getting your final answer as B by AC. Do pause the video and do try it and then verify your answer here. Be very, very careful in multiple places. In the very first thing is, when you're taking the LCM, this step has to be correct. And then when you're multiplying A alpha plus B multiplied by A beta plus B, right, individually, each term multiplied by every other term of the second expression. Be very, very careful. Do correctly each step. And even while cancelling, and when you are doing b plus b, it is 2b. Don't forget, b plus b is always 2b. Okay, and 2b minus b is b. So in these basic arithmetics, you have to be super careful. Now this is the first question. So we are done with the first question. So you have evaluated this expression. The answer is b by ac. Let's do the second one the same way. Okay, let me write it. The second question is beta divided by a alpha plus b plus alpha divided by a beta plus b. Again, you have to write, given alpha and beta are the zeros. Okay, so alpha and beta are the zeros of your f of x, which is given as ax square plus bx plus c. Okay, you know the sum of the zeros, alpha plus beta is equal to minus b by a, and alpha beta equal to c by a. Every time, even if it is the second question, the steps do carry the marks. So please do not skip writing these steps. Okay, so you are given alpha and beta are the zeros of the given polynomial. Do mention it and also write the sum of the zeros and product of the zeros and then start solving it. So beta divided by a alpha plus b plus alpha divided by a beta plus b. And just the same as we did in the first question, the first step is to take the LCM. So the LCM is the product of 2, a alpha plus b multiplied by a beta plus b. So in the numerator, the first term would be beta is already there, beta multiplied by a beta plus b plus alpha multiplied by a alpha plus b. Now let's multiply each term. So what you get here is a beta square plus b beta plus a alpha square plus alpha b. Okay, whole divided by a alpha into a beta plus a alpha into b plus b into a beta plus b into b is b square. Okay, so here what can we take common? What we can take is here, see, look here, in this two terms, you can take a common out. Okay, so a common, what will remain is alpha square plus beta square. And then in these two terms, right, b beta and b alpha, you can take b common out. So plus b, and then what remains is alpha plus beta. Whole divided by, multiply each term, so you get a square alpha beta plus ab alpha plus ab beta plus b square. Now in the numerator, you should know an identity. It is nothing but alpha square plus beta square. See, let me write it here. Alpha plus beta the whole square is equal to, it's in the form of a plus b the whole square. It's equal to a square plus b square plus 2ab. This is something which we know. Now, what will be alpha square plus beta square? Just rearrange it. So, if you have alpha square plus beta square on one side, you have to take this 2 alpha beta to the other side. So, what will be the expression or the identity? Alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. So this is a very important identity which is derived from a plus b the whole square, and this particular derived identity, it's called as derived identity. The first one is a plus b the whole square, which we have been using it for many years now. Okay, it's a basic, common, frequently used algebraic identity. But the second one, this is called the derived identity. It's derived from the above one. Okay, so learn it throughout your class 10th. This is the identity which you'll be using frequently. So alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. I'm going to replace it here. So what will the expression become? It will be alpha plus beta the whole square minus 2 alpha beta plus b into alpha plus beta whole divided by, in the denominator you have got a square alpha beta plus, again I can take ab common out, you have alpha plus beta plus b square. So now if you see, every term has either alpha beta, which is the product of the zero, or it has got the sum of the zeros. Okay, so now let me again continue writing. So instead of alpha plus beta, I am going to write it as minus b by a. Okay, so here you will write minus b by a the whole square minus 2 alpha beta is nothing but c by a, close the bracket, plus b multiplied by minus b by a whole divided by, in the denominator you have a square multiplied by alpha beta is c by a plus ab multiplied by minus b by a plus b square. Right? So now what expression do you have? A multiplied by b square by a square minus 2c by a minus b square by a whole divided by, you have in the denominator ac minus b square plus b square. So these two will get cancelled out, and a multiplied, the ones which are there in the square bracket, take a square as LCM. So you will have b square minus 2ac minus b square by a whole divided by ac. Right? Now again here 1a will get cancelled. So what remains is nothing but, again you can take the LCM as a. So b square minus 2ac minus b square whole divided by ac. Right, b square minus b square gets cancelled. So what you have is minus 2ac by a multiplied by 1 by ac. AC gets cancelled. So minus 2 by a remains. Okay, hence you have evaluated, hence valuated. Okay, whatever, or you can just write answer. So this is your final answer. Please definitely do try it once, and let me know if you're able to do these two questions. And if you have any doubts, please do post it in the comments. That's all for today. Let's continue the remaining questions of the polynomial. Hello everyone, welcome to Numeriq Learning. In the Do Math With Me series, wherein we are in day 17 today, we have been solving problems from class 10th, chapter 1, real numbers, and now we are doing polynomials. So today we will be solving 7 important questions. So these 7 questions are very, very important questions, and the similar pattern of questions have been repeated in almost many of the previous year's question paper. So in the Do Math With Me series, you will take your notebook, you will pause the video, write the question and do the solution with me, right? I will also be doing each and every question and I will be explaining it. At any point of time, if you have any doubts, you will post it in the comments. I will respond to it. Okay, in the very next video, I will probably solve it again, or I will reply to you in the comments if you have any questions. So let's get started. The first question for the day is, if alpha and beta are the zeros of the quadratic polynomial 2x square plus 7x plus 5, then find the value of alpha square plus beta square plus alpha beta is the question. The minute you see this sentence, right, alpha, beta are the zeros of the quadratic polynomial, immediately, first of all, let's write the given polynomial. So, the given polynomial is 2x square plus 7x plus 5. And you are given alpha and beta are the zeros of the quadratic polynomial. Immediately find out the sum of the zeros, which is equal to minus b by a, right? So here you have this is your A, this is your B, and this is your C. A is the coefficient of x square, B is the coefficient of x, and C is the constant term, right? So what is minus b by a here? Minus 7 by 2. Calculate the product of the zeros also, which is c by a. So 5 by 2. Now let us find the value. Once you have got your sum of the zeros and the product of the zeros, using these values we will be able to find the value of the given. So to find alpha square plus beta square plus alpha beta. Okay, so alpha square plus beta square, it is a derived identity. I would like to reiterate it here. So alpha plus beta the whole square equal to, it's using a plus b the whole square, a square plus b square plus 2ab, right? Then alpha square plus beta square will be equal to alpha plus beta the whole square minus 2 alpha beta. So this is an important identity which all of you should learn, and you'll have to use this. Okay, so here alpha plus beta, alpha square plus beta square, I will replace it with alpha plus beta the whole square minus 2 alpha beta, and then the remaining term as it is, which is plus alpha beta. Okay, so what is alpha? So everything you have to change, whatever you have to find, you have to change it in a way that everywhere you have either the sum of the zeros or you have the product of the zeros. Okay, only then will you be able to solve it. Okay, now what is alpha plus beta value? Alpha plus beta is minus 7 by 2. So minus 7 by 2 whole square. Again, what is minus 2 alpha beta plus alpha beta? It is minus alpha beta. So minus, what is alpha beta value? Let me write it here, minus alpha beta. So 49, 7 square is 49 by 4 minus alpha beta is 5 by 2. Take the LCM, it is 4. So 49 minus 2 multiplied by what will give you 4? It's 2 into 2. This 2 you have to multiply it with the numerator, which is 10. Okay, so the answer is 39 divided by 4. You can leave it as it is. This is your final answer. This is the value. Okay, so the minute you get your quadratic polynomial, whenever you are told alpha and beta are the zeros, immediately find out the sum and the product of the zeros. So sum of the zeros using the formula minus b by a, product of the zeros using c by a, keep it aside. Then start solving whatever you have to find. And make use of this. Change every term into the form either a plus b, alpha plus beta, sum of the zeros, or product of the zeros everywhere. So that you can replace these values. So that you can use these values. Okay, so this is how you have to do it. Do it once and let me know. Check if you are also getting 39 divided by 4. 39 by 4 is the final answer. Okay, let's move on to the next question. Quadratic polynomial 2x square minus 3x plus 1 has zeros alpha and beta. you have to form a quadratic polynomial whose zeros are 3 alpha and 3 beta. So as I told you, you are given 2x square minus 3x plus 1 is a quadratic polynomial and alpha and beta are the zeros. So immediately alpha plus beta, sum of the zeros equal to minus b by a, which is minus of minus 3 by 2. Yeah, b is minus 3, which is equal to 3 by 2. The product of the 0 is equal to c by a, which is 1 by 2. Right? So once I have found out, now I have to form a quadratic polynomial whose zeros are this, right? So the required polynomial, the zeros are 3 alpha and 3 beta are given. So let us find out the sum of the zeros, which is 3 alpha plus 3 beta, which is equal to, take 3 common out, alpha plus beta. What is alpha plus beta value from the given polynomial? It is 3 by 2. Okay, so here you're getting 9 by 2 is the sum of the zeros. Now let us calculate the product of the zeros. Okay, what is the product of the 0? 3 alpha multiplied by 3 beta, which is equal to 9 alpha beta. What is alpha beta value? 1 by 2. So 9 multiplied by 1 by 2, which is nothing but 9 by 2 again. Okay, so your sum of the required polynomial is also 9 by 2 and your product is also 9 by 2. So how will you write? Therefore, the quadratic polynomial is k multiplied by x square minus sx plus p. This is the formula. So k multiplied by x square minus 9 by 2 x plus 9 by 2. Take the LCM as 2. So you can take it out, k by 2. So numerator will have 2x square minus 9x plus 9. And when k is equal to 2, your outer 2 by 2 becomes 1. The required polynomial is 2x square minus 9x plus 9 is the required polynomial, whose zeros are 3 alpha and 3 beta. Okay, so very, very easy. From the given polynomial, get the sum and product of the zeros. For the required polynomial, you are given already that zeros should be 3 alpha and 3 beta. Get the sum of the zeros, get the product of the zeros. Substitute the value of alpha plus beta here. Substitute the value of alpha beta here. Get the new sum and product and put it in this formula. K multiplied by x square minus sx plus p. That's all. So this is your final answer. And when you have got k equal to 2. Okay, let's move on to the next question. If alpha and beta are the zeros of this polynomial, and you're also given one other information, that is 3 alpha plus 2 beta is equal to 20. Find the value of k. So as I told you, the minute you have your polynomial x square minus 6x plus k, find the sum of the zeros. Alpha plus beta equal to minus of minus 6 by 1, which is equal to 6. What is alpha beta? K by 1, which is k. Right? You are also given something more. Okay, these are for the given polynomial, you have found out the sum and the product of the zeros. You are also given 3 alpha plus 2 beta is equal to 20. Right? Now 3 alpha, I can write it as alpha plus, what can I write it? 2 alpha. 3 alpha, I can write it as 1 plus 2. Okay, so alpha plus 2 alpha is 3 alpha plus 2 beta equal to 20. Alpha plus 2 common out, alpha plus beta equal to 20. Alpha plus 2 into, what is alpha plus beta? It is 6 equal to 20. So alpha plus 12 equal to 20. Alpha is equal to 20 minus 12, which is equal to 8. Okay. Now you can substitute in any one of the equations. So we know that alpha plus beta is equal to 6. Alpha is 8. 8 plus beta equal to 6 and beta is equal to 6 minus 8, which is minus 2. Okay. So you have got the zeros of the given polynomial. Now you have to find the value of k. Isn't it? So how will you find out the value of k? What is k here? We know the product of the zeros is equal to k. So therefore, write down. Therefore, the product of the zero alpha beta is equal to, alpha is 8, beta is minus 2. It's equal to minus 16, which is nothing but your k value. Okay. Therefore, k is equal to minus 16. Is it correct? K is equal to minus 16. Write it correctly. And this is your answer. Right? If you know alpha and beta, you can just product multiply them and you will get the value of k. Because according to the formula, your product of the zero is equal to k. Clear? Let's move on to the next question. Okay, what should be added to the polynomial x square minus 5x plus 4 so that 3 is the zero of the resulting polynomial? Again, a very easy question. Let's write, let k be added. Okay, let there be a value k be added to the given polynomial. Okay, so when k is added to the given polynomial, what it gives you is the resulting polynomial. Okay, what you get is your resulting polynomial. So, x square minus 5x plus 4 is your given polynomial. Along with the given polynomial, you have to, what will you be doing? You will have to add a value k. So, plus k is your resulting polynomial. Let it be p dash of x is your resulting polynomial. Okay. Now, what is given is what should be added to this particular polynomial so that 3 is the 0. Now, since it's given that 3 is the 0 of your resulting polynomial, therefore, p dash of 3 is equal to 0. In place of x, just put 3. So 3 square minus 5 multiplied by 3 plus 4 plus k equal to 0. So 9 minus 15 plus 4 plus k equal to 0. 9 plus 4 is 13 minus 15 plus k equal to 0. So minus 2 plus k equal to 0 and therefore your k is equal to 2. This is your final answer. So what does it mean? 2 has to be added along with the given polynomial. You have to add a value 2 such that for the resulting polynomial, 3 is one of the 0. That means either alpha or beta is 3. Okay, so this is how you have to do. I hope you understood. It's a very easy question. Okay. So this p dash of x is our resulting polynomial. Let's move on to the next question. I hope you're also doing it. Please make a note of these. These are the questions which kind of, once you practice this kind, then it will be very easier for you. In similar terms, whatever you are asked in similar terms, right? Similar kind of questions you'll be able to, even if it is instead of added, if it is subtracted also, you'll be able to do it. Next question. If x plus 2 is a factor of the polynomial x square plus ax plus 2b and you are given a plus b is equal to 4, then find the value of a and b. Now, what are you given? Since you are given x plus 2 is a factor of x square plus ax plus 2b. Therefore, x equal to minus 2 is a 0. Okay, is a 0 of x square plus ax plus 2b. Okay, then so if this is your, let this be your polynomial p of x. So if minus 2 is one of the 0 of p of x, which means what? P of minus 2 is equal to 0. Let us substitute in place of x. Let's substitute minus 2. So what will you get? Minus 2 the whole square plus a into minus 2 plus 2b equal to 0. So what do you get? 4 minus 2a plus 2b equal to 0. So you have minus 2a plus 2b equal to minus 4. Let this be your equation 1. You are also given a plus b equal to 4. Right? A plus b equal to 4. Let us solve these two equations. Right? So, minus 2a plus 2b equal to minus 4. I am going to multiply this second equation by 2. So, what do I get? 2a throughout by 2 plus 2b is equal to 4 2s are 8. Okay, just I can add it up. So, I will be getting 4b equal to 4 and I will be getting b is equal to 1. This is the value of b. Let me substitute it. So, a plus b equal to 4, a plus 1 equal to 4 and a is equal to 4 minus 1 which is 3. Okay. Therefore, the value of a that I am getting is 3. Okay. So, this is your final answer. It's very easy. It's just that you should know if you are given x plus 2 is a factor of the given polynomial, you should know you have when you equate it to 0, x equal to minus 2 is a 0 of the given polynomial. This is what you know. And what do you mean by when x is equal to minus 2? When you say minus 2 is a 0, that means when you replace x with minus 2, the value is going to be, the polynomial value is going to be 0. That is why we write p of minus 2 is 0. And we find out, we first get a linear equation that is minus 2a plus 2b equal to minus 4. We already given another relationship, that is the sum of a and b is 4. Using these, just solve a pair of linear equations in two variables and get both the variable values a and b. Try it, do try it, and then verify if you are also getting a is 3 and b is 1. Hope you understood. Let's move on to the next question. If 2 and 1 by 2 are the zeros of px square plus 5x plus r, then find the values of p and r. Okay, now as we just saw, if you are given 2 and 1 by 2 are the zeros, okay, so let me write, since 2 and 1 by 2 are the zeros of the given quadratic polynomial, that is px square plus 5x plus r, therefore p of 2, that is, let this polynomial be, say, q of x. Okay, be equal to q of x. In that case, what should I write? Q of 2 is equal to 0 and q of 1 by 2 is also equal to 0. Then let's replace x with 2. So p into 2 square plus 5 into 2 plus r equal to 0. So you get 4p plus 10 plus r equal to 0. So 4p plus r equal to minus 10. This is your equation 1. When you replace x with 1 by 2, what do you get? P into 1 by 2 the whole square plus 5 into 1 by 2 plus r equal to 0. So you get p by 4 plus 5 by 2 plus r equal to 0. Right? Take LCM 4. So what do you have? P plus 10 plus 4r equal to 0. So you have P plus 4R. So when you cross multiply, this 4 will go to the right hand side. It will become 0. What you are left with is only P plus 4R plus 10. So I will take 10 to the other side. It becomes minus 10. So this is your equation 2. Now let us solve 1 and 2. Okay. So first equation is, I'm rewriting it again. 4P plus R equal to minus 10. Second one is P plus 4R equal to minus 10. Again, let me multiply this with say 4. So what do I get? 16P plus 4R equal to minus 40. I have P plus 4R equal to minus 10. Subtract it. Change the sign. So what do I get? 16P minus P. It is 15P plus 4R minus 4R gets cancelled is equal to minus 40 plus 10. Okay, whenever you change the sign, you should only consider this new sign. Okay, so minus 40 plus 10 is minus 30. So P is equal to minus 30 by 15, which is minus 2. So your P is equal to minus 2. Okay. Once P is minus 2, you can replace it anywhere. So say you have your P plus 4R equal to minus in any of the equations. What is P? Minus 2 plus 4R equal to minus 10. So 4R equal to minus 10 plus 2, which is minus 8. So 4R equal to minus 8, R is equal to minus 8 by 4, which is 2. So your R is nothing but minus 2. Okay, so you can write therefore P is equal to minus 2 and R is also equal to minus 2. That's all. So you have to find the values of P and R. You have found both the things, right? So this particular method, right, wherein you are eliminating one term, right, we are eliminating the R. In order to eliminate R, we have to make it 4. So we are multiplying throughout this equation by 4. And every term has to be multiplied by 4 so that when we subtract it, we can eliminate this. You can also multiply the second, in order to eliminate P, you can multiply the second term with 4 so that you can eliminate P. So this method is called as elimination method, which we will be studying in the next chapter. Okay, when in the third chapter, we will be, the chapter itself is pair of linear equations in two variables. So that throughout the chapter, predominantly, we will be learning about the substitution method, the elimination method, and how to find it. Okay. Let's move on to the next question. This is the last question of today. The question is, what should be subtracted from the polynomial x square minus 16x plus 30 so that 15 is the 0 of the resulting polynomial? So we just did it. You are, along with the given polynomial, what should be subtracted? Okay, so the resulting polynomial will be let it be, say, your f dash of x, right? It will be equal to the given polynomial, and what should be subtracted? Let k be subtracted from the given polynomial. Okay, so what should you write? X square minus 16x plus 30 minus k. Okay, so what are you asked? What should be subtracted from this polynomial? So let k be, you can write it. Okay, let k, you can write it here. Let k be subtracted from the given polynomial. Therefore, the resulting polynomial is nothing but f dash of x equal to, just write the polynomial and minus k. Now, what are you given? Since 15 is a 0 of the resulting polynomial, therefore, what is it? F dash of 15 is equal to 0. This is given. In place of x, just replace 15. So 15 square minus 16 into 15 plus 30 minus k equal to 0. 15 square is 225. Okay, what is 16 multiplied by 15? So is a 30, 6, 1. So 0, 240. Right? So minus 240 plus 30 minus k equal to 0. So what is 225 plus 30? It is 255. Minus 240 minus k equal to 0. So when you subtract these two, what do you get? 5, 15. So 15 minus k equal to 0. K, when you take it to the other side, it becomes plus k. So k is equal to 15 is your answer. So 15 has to be subtracted from the given polynomial such that 15 is a 0. Okay, so this is your value of k is 50. So this is how we do it. And in this do math with me, the whole idea behind me starting the series is to make students practice every day and get them a habit of, practicing every day. So a variety of problems every day. Now, if you had seen this video till the end, I am sure any kind of question of this kind, if you are also doing it along with me, you will definitely be able to do it. Okay. And one more very important announcement, do follow the series, do practice with me, and please join me at 6 to 7 p.m. every Sunday. We will be doing live YouTube live and doing some important MCQ questions from each chapter every Sunday at 6 p.m. If you just log in and check the Numeriq learning page, you'll definitely have a live starting. So do keep a reminder, 6 to 7 p.m. every Sunday. See you all there, and I hope you liked this video. If this was useful, please do consider sharing with your friends. Do subscribe, and happy learning. Thank you. Hello everyone. Welcome to day 18 of Do Math With Me series. This is exclusively for class 10 students who are preparing for board exams 2027. We have been doing it for the past more than 2 weeks, and it started with chapter 1, and right now we are in polynomials. We are about to complete polynomials. If you are new to the series, please do check out the previous videos within Do Math With Me. I also have separate playlists for the chapter itself, that is the first chapter, real numbers, and the second one, that is polynomials, and wherein everything starting from the exercise problems of NCERT and Exemplar, R.D. Sharma is also a part of it, and other reference books are all the important questions from the previous year's question paper are a part of Do Math With Me. So do check out if you haven't. Let's see 5 important problems today from the polynomials. The first question for the day is, find the degree of the polynomial x minus 1 multiplied by x square plus x minus x to the power 4 plus 2. The mistakes that students do is they take this term separately, they find out the degree, which is 1. What do you mean by degree? It is the highest power of the variable. Whatever is the highest power of the variable, that is what is called the degree of the polynomial, right? But here what you are given is nothing but a product of two algebraic expressions. So ideally what we have to do is, first of all, let us multiply the two expressions and then find out the degree. So let me write the given polynomial as it is: x minus 1 multiplied by x square plus x minus x to the power 4 plus 2. How do I multiply? First I would take x and multiply with each term of the second expression. Okay, and then minus 1 multiplied by each term of the second expression. Okay, let me start with x. So x into x square, it is x cube. X into x, right? I hope you are able to understand. X into x square, I have written x cube. X multiplied by x, it is x square. So plus x square minus x to the power 5 plus 2x. So I have multiplied x with all the 4 terms of the second expression. Now I am going to multiply minus 1. So minus 1 into x square is minus x square, minus x, minus into minus is plus x to the power 4, and then minus 2. Is there anything that we can cancel? I can see an x square and minus x square, which we have cancelled out. So you have got x cube is one term, minus x to the power 5. You can solve 2x minus x is plus x. Okay. And then plus x to the power 4 minus 2. This is what you get when you find the product of the two expressions. Now what is the variable here? Variable is x. What is the highest power of x? In the first term, it's 3, 5, and then it's 1, 4. So what is the highest power? It is 5. So therefore, the degree of this polynomial is 5. Okay, therefore, the degree of the polynomial is nothing but 5. Okay, this is your answer. Let's go ahead and do the second question. If m and n are the zeros of the polynomial which is given by 3x square plus 11x minus 4, find the value of m by n and n by m. Let us go ahead. The minute you are given m and n are the zeros of the polynomial, let us say your p of x polynomial is given as 3x square plus 11x minus 4. So what is the sum of the zeros here? The sum of the zeros is given by m plus n. You are taking m and n as a 0. So m plus n is equal to minus b by a. So it's nothing but, here what is a? A is nothing but your 3. Right? The coefficient of x square. What's your b? B is the coefficient of x, which is 11. And what is your c? C is minus 4. So these are called the coefficients of the polynomial. So sum of the zeros is nothing but m plus n equal to minus b by a, which is nothing but minus 11 by 3. Okay. So the product of the zeros. What is the product of the zeros? That is m into n is equal to c by a. What is c? Minus 4 by a is nothing but 3. Correct? Now what we have to find out? To find m divided by n plus n divided by m. So take the LCM. LCM is nothing but mn. So the numerator will have m square plus n square. Now this is a very important identity to remember. Always remember, m plus n the whole square is nothing but a plus b the whole square. A square plus b square plus 2ab. Therefore, what is the formula for m square plus n square is equal to m plus n the whole square minus 2mn. Okay, this is a derived identity. So let me write it here. M plus n the whole square minus 2mn whole divided by mn. So everything we have brought it to the form sum of zeros and product of the zeros. What is m plus n? Minus 11 by 3. Right? So you have minus 11 by 3 the whole square minus 2 multiplied by, what is mn? 4 by 3. Right? Minus 4 by 3. Whole divided by, again, minus 4 by 3. Now we have to solve it. Let me just shift the question a little below so that I have space to do. Okay. So what is minus 11 by 3 the whole square? 11 square is 121. So 121 divided by 9 plus 2 4s are 8 by 3 whole divided by minus 4 by 3. Okay. Then in the numerator, what is the LCM? It is 9. 9 is the LCM. So you have 121 plus 24 whole divided by minus 4 by 3. I will write it as minus 3 by 4. I can take a reciprocal or flip it. When I take the denominator fraction to the numerator, I can flip the numerator and denominator. Okay. So what do you get here? 121 plus, so it's 145. 3 and 3 3s are 9. Right? So it is nothing but you have a minus sign. Minus divided by minus 145 divided by 3 into 4, which is 12. So this is your answer. Whatever expression you have got, right? See, you had to find out what is m by n divided by n by m. You have taken the LCM and just substituted. But in order to do that, you should know there is nothing called, you don't know the sum of the squares of the zeros. So you should remember this identity, which is m square plus n square equal to m plus n the whole square minus 2mn. So you can replace the numerator with that, and then the sum of the 0 is minus 11 by 3. Just substitute in place of m plus n, and in place of mn you can just substitute minus 4 by 3 and calculate it very correctly. Take care of the signs also. Okay, so the final answer is minus 145 divided by 12. I hope all of you got it. Let's move on to the next question. Please do pause the video and make sure you solve it. Okay, if you are getting any other answer, probably you would have missed while doing this arithmetic, basic arithmetic. Some mistakes would have happened. Minus into minus is plus, or minus the whole square is again plus. 11 square 121 by 9. Just take care. Just check if everything is correct. Let's move on to the next question. If alpha and beta are the zeros of the quadratic polynomial, which is given by P of S is equal to 3s square minus 6s plus 4, you have to find the value of this particular expression, which is in terms of the zeros, alpha and beta. Everywhere you have alpha, beta. The minute you are given this polynomial, let us calculate what is the sum of the zeros and what is the product of the zeros. So first let me write the given polynomial as it is. Okay. So it is nothing but 3s square minus 6s plus 4. What is the sum of the zeros? Alpha plus beta is equal to minus b by a. Minus b by a. So minus b is minus 6. I'm putting it in the bracket. Divided by a is 3. So 6 by 3, which is 2. And what is alpha beta? It's equal to c by a. What is c? 4. 4 by 3. So alpha beta is nothing but 4 by 3. Now let's see what you have to find. So let me start from here. To find alpha by beta plus beta by alpha plus 2 multiplied by 1 by alpha plus 1 by beta plus 3 alpha beta. For the first two terms, take the LCM. Okay. Let this be separate. For the first two terms, take the LCM. So you will have alpha beta, alpha square plus beta square plus 2 multiplied by same way. Take the LCM. LCM is alpha beta. So here, right, what I'm doing is this one. 1 by alpha plus 1 by beta. The LCM is alpha beta. So in the numerator, you will have alpha plus beta. Okay, plus 3 alpha beta. Okay. Now, I just told you the formula for alpha square plus beta square in the previous question. It is nothing but I'm going to write it here. Alpha plus beta the whole square minus 2 alpha beta whole divided by alpha beta plus 2 multiplied by alpha plus beta divided by alpha beta. Okay. And then the last third term is 3 alpha beta. Now everything is of the form, if you see here, alpha plus beta, there is a sum of zeros and product of the zeros. Every term has been changed to the form of sum of zeros, and now you have to just substitute the value. What is the sum of the zeros? That is alpha plus beta. It is 2. So 2 square minus 2 into 2 multiplied by 4 by 3 whole divided by 4 by 3. So plus 2 multiplied by what is alpha plus beta? 2 divided by 4 by 3 plus 3 multiplied by 4 by 3. Okay, so 3 gets cancelled here. What do you get? So 4 minus 8 by 3 whole divided by 4 by 3 plus what do you get? 4 divided by 4 by 3 plus 4, right? So here, what is the numerator here? Take the LCM in the numerator. So you will have, this is by 1, right? So it's 12 minus 8. So it's 12 minus 8 whole divided by 4 by 3 plus 4 into 3 by 4. Okay, I'm just going to flip it, plus 4. So 4 gets cancelled. This is nothing but 8. I can replace this 12 minus 8 by 3 as 4 by 3. So 4 by 3 will get cancelled. So the first term will be 1 plus 3 plus 4. So what is it? 4 plus 3 is 7. 7 plus 1 is 8. So the final answer is going to be 8. So it's very, very easy. It's just that when you see a polynomial and when you are told alpha and beta are the zeros of the polynomial, immediately find out the sum of the zeros, and find the product of the zeros. Based on the values, you can substitute and solve whatever you have to find in terms of alpha and beta. You can use it, and this is one identity which you have to learn. Alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. So in that case, everything else is transformed. So replace the values that you have got. Let's move on to the last question of the day. You are given a polynomial. This is actually a question from the case study, but I have not mentioned any of those stories that the boy is throwing a ball which is in the form of a parabola, and the graph of the path that the ball traces or the stone traces is given by this polynomial. So I have not written those theory or stories of the case study. I have only written what is the main information in the case study question. You are given P of t equal to minus 2t square plus 7t plus 4. This is given to you. You have to write the name and degree of the quadratic polynomial. What is the name? What is the degree of the polynomial? So here in the given polynomial, the variable is t. The highest value of t, highest power of t is 2. So the degree is 2. Okay, the first answer is the degree of this polynomial is 2. What is the name? If the degree is 2, it is called a quadratic polynomial. Okay. It's a quadratic polynomial. That's all. This is the first answer, first 1 mark. Okay, this is actually a 4-mark question. Second one, find the factors of P of t. You have to find the factors of P of t. How do we do it? Let us write the given question first of all. You are given the polynomial minus 2t square plus 7t plus 4. Okay. How do you find the factors? Let's use the middle term splitting. Get a sum and get a product. So what is the sum? Sum is nothing but your b value, the coefficient of t, which is 7. What is product? A into c. So a is minus 2 into c is nothing but the constant. So minus 2 into 4 is minus 8. So again 8 and 1, and you have, if you put a negative sign, you're just finding out two numbers whose product is 7 and whose sum is 7 and whose product is minus 8. So the two numbers are 8 and minus 1. Just replace the middle term, so you'll be getting minus 2t square plus 8t minus t plus 4. We are just doing the middle term splitting. And if you take say 2t common out, what do you get inside? Minus t plus 4, right? Again plus 1 common out, minus t plus 4. So what are the factors? You have minus t plus 4 common out, and the leftover is 2t plus 1. These are the factors of the given polynomial. Factors of P of t. That is your second question. This is the answer for your second question. What is the third question? The number of real zeros are. So in order to find the number of zeros, you have to equate. Okay. So to find the number of zeros, you have to equate your polynomial P of t to 0. So you don't have to redo it. Whatever you have got as a factor, that you can equate it to 0. Minus t plus 4 and 2t plus 1 is equal to 0. So what do you get the value of t? Either minus t plus 4 equal to 0, which means t is equal to 4. This is 1, 0. or 2t plus 1 equal to 0, which means 2t equal to minus 1 or t equal to minus 1 by 2. So how many zeros have you got? 2 zeros, right? This is one 0 and this is the other 0. These are the zeros of the given polynomial. So the number of real zeros are 2. Okay. And last question, where will the graph of p of t cut the x-axis? Where will the graph cut the x-axis? Obviously at the zeros, right? So the fourth point is the graph will cut the x-axis at the graph will cut the x-axis at x is equal to 4 and at x equal to minus 1 by 2. Okay, so at these 2 points, these are the only 2 points which are the zeros of the polynomial, hence your y is going to be 0. Okay, at x equal to 4 and x equal to minus 1 by 2. So at these 2 points, your graph will cut the x-axis. So this is actually a case study question and 4 questions, 1 mark each. Very, very easy question. So never bother about all those stories that are written here. Sometimes I have seen questions which say, there is the beehive, okay, which is in the shape of a parabola. And then you'll be given the polynomial and then all of these questions. So don't even read anything which is written above it. Okay, because that's not at all relevant. All you have to observe is what is the polynomial given and what are the questions that follow. So these are the questions which you can directly answer. I hope you understood. Do make a note of it, and I hope this was useful. You learned something out of these 4 questions that we did. Also, another announcement is, apart from you checking all the other videos of Do Math with me, do join me live on Sunday at 6 to 7 p.m. IST for doing MCQ questions. So there will be a 1 hour live session every Sunday, and it's chapter-wise, one chapter at a time. So do join me at 6 p.m. on my channel Numeriq Learning, and let us do problems for an hour. Thank you so much. Happy learning, and do leave your feedback in the comments. If you have any questions, drop that in the comments, and do share and please do subscribe. Thank you.